It's on you. Good.
Okay, today we're going to be talking about graphing piecewise functions. What is a piecewise function? It's a function where they are in pieces. So it's parts of a graph, not the whole graph. So that might be stopping and starting, going on forever to infinity. So the worksheet that you have there and assigned to you, I'd like you to have that printed out. Definitely have this for your notes. So we're going to be doing numbers 1, 2, and 4 together. And then you're going to be working on 3, 5, 6, and 7 for homework for practice. Alright, so let's take a look at this piecewise function. How do I know it's in pieces? Is because each equation that I'm giving you has a certain restriction at the end of it. So you have to be able to understand what this is saying. So this is saying that I need to graph f of x equals x plus 5. All my x's have to be that the less than symbol, less than negative 2. And then I'm also going to be graphing this quadratic equation. F of x equals x squared plus 2x plus 3. All my x's here are going to be greater than or equal to negative 2. Alright, so when we start doing this, one of the first things that I think would organize it easier for yourself is set up a table for each of these functions that we're going to graph. So I want to graph x plus 5. I'm going to have my x column, my equation, and then my output, because I'm going to be plotting a couple of points. So I'm going to be starting with whatever it says in my restriction. Here it says I need to start with negative 2. I plug in negative 2 for x, I have my 5, and I get 3. So the point that I would plot is negative 2, 3. If there is no equal sign underneath, if you have a less than or a greater than symbol, that means you're going to have an open dot, not solid on the point. If you have a symbol with the equal sign under it, you're going to have a solid dot on that specific point, solid dot. Alright, so let's go ahead and plot that point, negative 2, comma 3. So I'm going to my x-axis here, negative 2, up to 3. It's right about here, except because it has the restriction of this with no equal sign under it, that means it's going to be an open dot right on top of there. Now I need to know the direction that this line is going, so I need to input another number that's less than negative 2. So what number is less than negative 2? I could do negative 3, negative 4, whatever you want. I'm going to do negative 3. Plug it in the equation, negative 3 plus 5. My output there is 2. So I'm going to plot the point, negative 3, comma 2. This is telling me my direction, so it's about here. That means I'm going down in this direction forever, forever, so I'm going to put an arrow. There is nothing at the end stopping it, so there's an arrow in that direction. Alright, now I'm going to graph the next one, which is x squared plus 2x plus 3. Get my output. Alright, what number should I always start with? With whatever they give you here. Here it's negative 2. Let's input negative 2 in for the x. Let's be careful with order of operations. Negative 2 squared is 4. Negative 2 times negative 2 is negative 4 plus 3. Subtract and add. My output there is negative 2, comma 3. So here it happens to actually land on the same dot that I had for this one here. But because it has an equal sign, that means I'm actually going to have it as solid. So on top of this, it's actually a solid dot right there. What other number should I input for this line, for this quadratic? Something that says greater than negative 2. So I could have anything past this line, negative 1, 0, 1. I'm going to do a couple of different numbers. I'm going to do 0, and I'm going to try 1, both of them, just to see where the direction of this parabola is going. So I'm going to plug in 0 for my x there, each of these x's. 0 squared is 0, plus another 0, plus 3 is 3. So I'm plotting the point 0, 3. I'm going to also plug in 1. Let's plug in 1. Work that out. That's 1 plus 2 is 3. 3 plus 3 is 6. I'm finding the point 1 comma 6. So I have here 0, 3. 1, 6. 1, 2, 3, 4, 5, 6. So I still need to know where this curve is going here. So I'm going to do negative 1. So I'm going to go over here. I have enough room over there. So I'm going to plug in negative 1. So negative 1 squared. 2 times negative 1 plus 3. So I got 1 minus 2 plus 3. Negative 1 plus 3 is 2. So negative 1, 2. So this is telling me where that curve is going for that parabola there. So here it is, down and then up, and it's going to keep going on forever for infinity because it's everything that's greater than negative 2 on the x-axis. So there's the graph of my piecewise function. We got this piece of the line and this piece of the parabola. Is this a function? Yes, it is, because if I do the vertical line test, it doesn't pass it over twice. And now they're asking you to do these two things here on that worksheet. How would I figure out f of negative 4 and f of negative 2? Alright, so f of negative 4, we need to go back over here and look at these lovely restrictions. Well, which one says negative 4 is part of the restriction? This was greater than negative 2. This was less than negative 2. Negative 4 is obviously less than negative 2. So I'm going to plug in negative 4 in this function, not this one. So when I plug it in, I get my output to be 1. So the answer for f of negative 4 is 1. Then I'm going to the next one, f of negative 2. I believe we did do that one. I erased it. Well, which function actually includes negative 2? It's this one here because it says it equals negative 2. And when we inputted that in, what did we get for negative 2? I believe we got our answer to be 3. Right, you can move it down. Alright, now let's take a look at number 2 on that worksheet. Again, we're graphing these two functions here. One's a line, one's again a parabola. Here are the restrictions for these. So here I got 2x plus 1. All my x's are greater than or equal to 1. And this one, the restriction, less than 1. Alright, so let's do this one first. Let's set up our table. And again, what number must I always start with? With whatever is given there. So that's 1. I'm going to plug in the 1. 2 times 1 plus 1. I get my output to be 3. I am plotting 1 comma 3. Is this going to be an open or a solid dot on 1 comma 3? Let's go back and look at it. This means a solid dot. Let's go to 1, 3. Solid dot. Right there. Right now we need to know the direction of this line. Anything that's greater than 1. So I'm going to take 2. Plug in 2 in the x. 2 times 2 is 4 plus 1. I get it to be 5. 2 comma 5. So that means 2 comma 5 about here. It's starting here and it's going up in this direction with an arrow. It's going to keep going on forever, forever. Now we're on to our next line. Excuse me, quadratic actually. X squared plus 3. Alright, what number again must I start with? Whatever is there. That's 1 again. Plug in 1. What's 1 squared plus 3? That is 4. 1 comma 4 is what I'm going to plot. What kind of dot do I have on the 1 comma 4? If I go back up here, it's going to be open, right? It doesn't have an equal sign. So 1 comma 4. So right here, open. So I got the solid there from the other line. Here, this quadratic is right there. Alright, what other point am I going to choose? Anything less than 1. Alright, so let's do 0. Well, let's do negative 1. Plug in 0. I get my output to be 3. 0, 3. Right here, so it's going this way. And I'm assuming it's going to go up because it is a quadratic, a happy face. So let's plug in negative 1. I got 1 plus 3 is 4. Negative 1, 4. Right here. So, yes. And it keeps going on forever. There is a break in this graph here, if you notice. It stops and then it starts here. So So let's see if we can answer these three questions. What's f of negative 2? All right, which one would I look at? Which of these two restrictions has negative 2 in it? It's this one because it says less than 1. Negative 2 is less than 1, so I'm going to plug in negative 2 here and get my answer. Whoops. And that answer is 7. Same thing. Which one would I plug in 6 for? 6 has to be the one where it's greater than 1, because 6 is greater than 1. I'm going to plug in 6 in this equation. So that's 12 plus 1 is 13. And now where would I plug in 1? Well, which one includes the 1? This one right here, because it says equals 1. And I believe we did that from before, right, when we plugged it in. Our answer was 3. Okay, can we go over here? Alright, last one we're going to look at, we're skipping 3, because I want to take a look at number 4. Number 4 has something a little different. This has 3 pieces of a graph. Alright, so it's got a quadratic, it's got a line, and then it's got a number here. Alright, so let's start all over the process again. So we're going to set up our table. Alright, what number should I plug in for x squared minus 1? Well, this restriction, all my x's are less than or equal to 0, so I'm going to start with 0. 0 squared minus 1 is negative 1. So I'm going to plot the point 0, negative 1. And what kind of dot is this going to be to start my graph? Solid, because it has an equal sign. So 0, negative 1, right here. Alright, now I need anything less than 1, less than 0, excuse me, so let's do negative 1. This is 1, minus 1 is 0. I'm going to plot negative 1, 0. I could choose another one if I'd like. We could, negative 2 squared minus 1. That gives me 3, negative 2, comma 3. Alright, so this is where it's going. It's starting here, and it's going up in this direction. It's a little slight curve. Even if you don't have a curve, it's fine. But this is the direction it's going for this parabola. Alright, now we're doing 2x minus 1. What number must I plug in? Alright, here is where it's a little different. We have a restriction now, compound inequality, and here it says all my x's are less than or equal to 5, and all my x's are, you're reading it backwards there, greater than 0. So I have a restriction from 0 to 5. Alright, so let's start with the 0. This is 0 minus 1 is negative 1. I am plotting now 0, negative 1. What kind of dot on the 0? This is going to be open. So let's go to 0, negative 1. 0, negative 1. Right on top of this one happens to be an open circle on top of the solid. I could input other numbers in here if I'd like. 1, 2, 3, 4. I'm just going to go ahead and do where it's going to actually stop now. So this is where it's different from the other ones. This one's actually stopping at 5. So let's plug in 5. I got 10, minus 1 is 9. I am graphing 5, plotting 5, comma 9. 5, 1, 2, 3, 4, 5. Just try to hold it then. 5, comma 9 is right here. And that's going to be a solid dot because it has the equals solid. So I'm going from here to here, and I am connecting them. There is no arrow because we're starting at 0 and ending at 5. So that's how it's different from the other problems. Alright, last one. This is very different. Here I'm saying f of x equals 3. Well, remember, what does f of x stand for? F of x is our range, our output, which is y. Anyone remember how to graph y equals 3? Well, here's my y-axis. Y equals 3 is going right through 3 as a horizontal line. Now, does it want us to include everything on this y equals 3? Well, what's the restriction? It says all my x's have to be greater than 5. So I'm going to be going to x equals 3 line, right? Y equals 3. But I want to go to 1, 2, 3, 4, 5. right here, 5, comma 3. Now, before I start and make the line going horizontally, what kind of dot is going to be on the 5? This one is going to be open. So I'm going to do this in a different color. Let's do it in green. It's going to be an open circle right at 5, comma 3. Where does the horizontal line go? It says everything that's greater than 5. So all these numbers on my x-axis, 6, 7, 8, everything after are greater than 5. So here is where it's going. So I've got this piece of the graph, this one for the line, and then another horizontal line looking like that. So let's see if we can get the answers for this last piece here. F of negative 2. Well, which one of these lovely restrictions has negative 2 in it? Definitely not this. These are all positive. Less than 0. Yep, that's negative 2. So I'm going to plug in negative 2 in that quadratic, and I get it to be 3. Which one is F of 0? Well, we got two different zeros going on here. Which one actually includes 0? Again, it's this one with the equal 0, x squared minus 1. So I'm going to do 0 squared minus 1. I get negative 1. And then which one has F of 5? Well, look, we have 5 here, we have 5 here. Which one actually includes the 5? Well, it's the one with the equal sign, so it's this equation here. So I'm going to do 2 times 5 minus 1, which I think we did already. 9, yeah. So those are the answers for number 4. So I would definitely look over number 3, try it, and 5, 6, and 7 I have online for the answer keys for you to take a look at.